Hello everybody, and welcome to Point Fermin, California. You all happen to stumble upon an area with great geological activity. Our little Point Fermin sits upon a magnificent coastal bluff created by wind and wave erosion. When an area is created by wind and wave erosion, it has the potential of being destroyed by the same processes that created it. Now keep that in mind as this video progresses. To most of the residents in local Southern California, Point Fermin is known as Sunken City. A random but preventable geological accident occurred in 1929. And according to Michael Scullin's paper, Point Fermin Landslide, our famous local attraction was created by sea wave erosion undercutting the side of the Palos Verdes Peninsula, specifically the Altimara Shale. A lack of proper environmental planning led to the eventual landslide. Keep in mind, coastal processes have not changed, but humans have increasingly used and developed the shoreline, thus creating a hazard for both the coast and the people who reside in and around them. Now, to describe more about the processes that occur at Point Fermin, here is Layani talking about landslides.
Landslides are the movement of masses of rock, debris, or earth down a slope. Landslides are able to travel miles from its initial source, enlarging its size, picking up houses, trees, cars, boulders, and other materials. Landslides are more likely to occur in areas where the slopes are already on the verge of movement by rainfall, snowmelt, changes in water level, stream erosion, earthquakes, volcanic activity, or a combination of these various activities. Particularly in Southern California, where earthquakes occur frequently, most of the landslides that happen are caused by earthquakes. As far as Point Fermin, the area is completely surrounded by the Pacific Ocean, indicating its vulnerability to landslides, while also taking into account Fermin's location, which is in San Pedro, where rain does occur in due season, which doubles Fermin's risk of landslides. In addition, Fermin's weak bedrock is caused by bentonite, which is a clay-like sediment that is easily decayed by wind, rain, and moisture, which results in a weak surface. The water coming from the ocean is constantly clashing the bedrock that surrounds the area, eroding its stability to maintain its form.
In
Now let's
open
talk
ocean,
about
wave
waves.
motion is circular. The circles decrease in diameter as depth increases. There are two main types of waves. The first are plunging breakers. Plunging breakers are more erosive and pick up very quickly. These are typically seen on steep beaches on the west coast. The second are spilling breakers. These waves spill gently and are more likely to deposit sand. These are typically seen on wide flat beaches on the east coast. All kinds of waves affect our coast and shores. When water is constantly hitting the coast, it eventually causes erosion. It breaks down the rock, moving sand and other sediment. The more force the wave holds, the bigger the impact. Waves can also erode land by the process of abrasion. This is when they pick up sediment, wearing the rock down as the water pulls back. The rock in which Point Fermin sits on is known as the Monterey Formation. This is a large assembly of rock stretching through most of Southern California. The sedimentary rock that composes this formation were deposited in a deep marine environment. As they were exposed to land, the strata were uplifted by plate tectonic forces. This is why it looks as if it is in different levels defined by color. Particularly at Point Fermin, wave erosion cuts away at the bottom level rock, creating a sort of cliff. This rock is very weak, mainly made of mudstone and shell. What this process has created is the coastal bluff in which Point Fermin sits on.
Coastal bluffs are bedrock outcrops, rocky islet, and steep cliffs that are located close to the ocean. They form a transition between marine shorelines and forests such as coastal Douglas fir and a coastal western hemlock ecosystem. Coastal bluffs are described by little or no soil, and the soil that is present is usually low in nutrients. It all started with the devastating news of the earth movement that first was detected in the area near Shepherd between Paseo del Mar and Pacific Avenue on January 2nd, 1929. In early May, people noticed a lateral movement of 8 inches and a vertical drop of 3 inches since January. By August 1929, the movement had been described as a full-on landslide with earth moving toward the ocean at the rate of 3 inches per day. A large crevice cervical had formed. An earthquake and flooding from storms in 1940, along with a water main break in 1941, reportedly contributed to the additional severe landslides, making the land even more unusable. One factor that is the lapping of waves below the bluff, which weakened its structural integrity. The other reason was the presence of clay called bentonite in the ground. Patches of bentonite were formed from the compression of volcanic ash. When the clay came into contact with water from rainfall or residential irrigation, the land became extremely unstable.